So sometimes I can introduce fractions and it's not really going to change anything. So let's say I introduce this problem. Sorry, I didn't mean fractions, I meant variables. So let's say I have 7 over y and 6 over 11, and I want to find the LCD of that. So I'm simply going to do the same thing I just did. So I'm going to break up the prime factors of y, and we don't know what y is, so we're just going to assume it's y. And the prime factors of 11. And what are the prime factors of 11?
None.
11. It's already a prime number. I'm going to circle the greatest number of times each one appears. So what's my LCD here? 11y. Simple as that. Can I turn the page? Okay. Let's talk about equivalent fractions for a second. And this will all come together soon, I promise. So equivalent fractions. So do you remember what an equivalent fraction is from when we started doing fractions? So what are two equivalent fractions?
Fractions that equal each other.
Fractions that equal each other that represent the same portion of the pie, right? So remember I drew pictures out and I said, let's say we have 2 pies. Let's say this one's divided into 4 pieces and this one's only divided into 2 pieces. And I select 2 pieces out of this pie. What's this fraction right here?
Yeah.
2 quarters. And I select only 1 piece out of this pie. What's this fraction? 1/2. But in both cases, I'm really selecting half of the pie. It just so happens in this case I'm doing it choosing 2 out of 4. This one I'm doing it choosing 1 out of 2. But in both cases I'm representing the same part. That's why these are called equivalent fractions. And how can I check if they're equivalent? Reduce both of them and see if they equal the same thing, right? Okay. So now we're going to kind of do the opposite. We're going to start with a fraction that's already reduced, and we're going to write it as an equivalent fraction with a different denominator. So let's say we have... So let's say we want to write 7/8 as an equivalent fraction with a denominator of 56. So I have 7/8 and I want to write it with a denominator of 56. So what can I multiply by 8 to get it to be 56? 7. Okay. Now remember rules for multiplying fractions. I need to multiply the fraction by 1 in order to not change its value. If I multiply it by anything other than a number over itself, I'm going to change the fraction's value. 7 over 7 evaluates to be 1, so I'm not really changing anything when I multiply by 7 over 7. It's the same thing as if I multiply by 1. So the numerator here becomes 49, and the denominator is 56. And I got exactly what I wanted. I got a denominator of 56, and I'm representing the same portion because these two fractions right here are equivalent. So in general, let me just write the rule out. If you have a fraction a over b, you can take a over b and multiply it by c over c and get a times c over b times c. And what all this is saying is that you can multiply any fraction by a number over itself and you're not changing the value of the fraction. All that you're doing is you're changing the way it looks, but you're still writing an equivalent fraction. So let's do another example so it sinks in a little better. So let's say I have 1/4 and I want to write it as an equivalent fraction with a denominator of 20. What can I multiply a quarter by to have a denominator of 20? Yeah. But remember, whatever I do to the denominator, I have to do to the numerator as well. So the numerator ends up being 5 over 20. And you can check that these two fractions are equivalent, right? You know how to do that from before. Just reduce one of them and you should get back to 1/4. Let's say you want to have 3x over 7. You want to write it as an equivalent fraction with a denominator of 42. What can I multiply that one by? 6 over 6. What does the numerator give me here?
15x.
15x? 18x?
18.
Yeah. Okay. So I'll give you a couple to try as well. Try converting the number 4 to an equivalent fraction where the denominator is 6. And try changing 9 over 4x to an equivalent fraction with a denominator of 36x. So what is the first one? How can I convert that to an equivalent fraction? So you can think of the 4 being over 1, and then you multiply the top and the bottom by 6. You get 24 over 6. You can verify because if you divide 24 into 6 into 24, you get 4. Okay? What I need to multiply the second one by? 9. So my equivalent fraction is 81 over 3x, 36x. Questions before we move on?